Hello, this is Dr. Mateki. We're going to go over the solutions to the tax homework, problem number 2. So in the problem, you are giving the supply and demand equations for gizmos, and ultimately what we're going to do is analyze the effect of a $2 per unit tax on this product. So first what we're going to do is look at the initial equilibrium, and then we'll look at how the equilibrium changes after we institute the tax. Okay, so in the problem, the quantity demanded was given as 2,000 minus 100 times the price. Quantity supplied is equal to negative 100 plus 200 times the price. And so we can pretty easily graph these curves by finding the x and y intercepts. For instance, with the demand curve, we can set price equal to 0 and see that the x-intercept is 2,000. We can set quantity equal to 0 and find that the y-intercept is 20. This is a linear equation, so we simply connect these 2 points to get our demand curve with the supply curve. We can find the y-intercept in the same fashion, and it turns out to be 0.5. And we don't need to find the x-intercept, but that is going to fall over in this region over here, so we just know that it's going to be upward sloping and look something like what I've shown here. If we want to find the initial equilibrium, we need to find the point where the curves intersect, so that amounts to setting QD equal to QS. So when we do that, we have the expression for QD here, the expression for QS here. Now we have one equation with one variable. We can solve for price. When we do that, it turns out to be $7. And so the point of intersection, if we look at right here, the equilibrium, we go to the y-axis, and that's gonna be $7. To find the equilibrium quantity, we plug 7 back into either of the expressions for QD or QS. So I chose QD, so what we want to find is the quantity. So the quantity is equal to 2,000 minus 100 times the price, an equilibrium price. And we solve for QD, and it's 1,300. So our initial equilibrium is a quantity of 1,300 gizmos selling at a price of $7. All right, so the next step is to find the after-tax equilibrium. And to remember the effect of a tax, so this is a sales tax, so this is effectively, we can model this as a tax on sellers. The sales tax is therefore going to shift the supply curve up by the amount of the tax. So we shift it in a parallel fashion, so what's going to happen is the y-intercept is going to increase by 2, and the slope is going to stay the same. So it's going to be helpful to convert the supply curve to slope-intercept form, which means we need to solve for the y variable. Y equals mx plus b plus the y-intercept. We've already decided, or found out rather, that the y-intercept is equal to 0.5. We now know the slope is 1 over 2,000. And so we can take this y equals mx plus b form and see what happens very easily when we increase the y-intercept by 2, right? In other words, shift it up in a parallel fashion by 2 units. We now see that the price is equal to 1 over 2,000 times QS. This is the slope. It has not changed. The y-intercept goes from 0.5 to the sum of 0.5 and 2, or 2.5. Right, now that we've determined the equation for the supply curve after the tax right here, we can plot this in a fairly straightforward manner. We know the y-intercept is going to be 2.5. The slope is going to be the same, so we can draw the new supply curve, shift it up from the old one. So this new supply curve is going to be the supply after the tax has been taken into consideration. So the new equilibrium point where the new supply curve hits the demand curve right here, this is going to give us what we call the gross price, or the transactional price. This is what the buyer is going to walk into the store and pay for the good, and that includes both what they're paying for the good and the tax. Okay, so buyers pay this price here, but sellers don't get to keep all of this because they're responsible for sending the tax to the government. So they get to keep the price that sellers receive. I've called this PS. So they get to keep whatever the buyers pay minus the amount of the tax. So the difference between PB and PS is the $2 per unit tax. So we know the difference between PB and PS is the $2 tax. And so ultimately what we want to figure out is how much of that $2 tax is actually borne by buyers and how much is borne by sellers. In other words, what is the tax incidence that falls on each party? We also want to know how much quantity goes down after the tax is implemented. After we shift that supply curve up, we can drop down to the x-axis to figure out what this after-tax quantity is. Right, now that we have our after-tax supply curve and our demand curve, we need to do the same exact exercise we did to find the initial equilibrium. We're just using a new supply curve, same exact process. So we've already converted this to y equals mx plus b form. In other words, we've solved for the price and the supply curve. So we either need to go back and turn this into the previous form, or we can convert demand to y equals mx plus b form. They both need to be in the same form at the end of the day. So I converted this to y equals mx plus b form. We can then set these two equations equal to each other to find the equilibrium quantity, right? And so the QS and the QD, we can just drop the S and the D because an equilibrium QS is equal to QD, so there's really only one quantity. So once we set those two expressions equal to each other, we can solve for Q, and it turns out that we get 1,166.7 for the quantity. Now, when you're solving, doing a little algebra up here, if you want to get rid of these fractions, you could multiply everything by 200, for instance, if you wanted to eliminate the fraction here and the fraction here, if that makes it easier for you. To find the equilibrium price, then we just take the Q that we found, plug it back into either the after-tax supply curve or the after-tax demand curve. I chose to plug it into the after-tax supply curve. So when we do that, we get 8.3, which really is $8.30 because that 8.3 refers to the variable on the y-axis. That's the price. So in other words, what we found is the price where the new supply curve hits the demand curve intersects with the demand curve. That is the price that buyers pay. So $8.30 is the PB. We can now find PS very easily because we know that PS is equal to the price that buyers pay minus the tax, which was $2. So PS must be $6.30. That's what sellers get to keep. We can also look and find the incidence very quickly now. So the incidence is the difference between the equilibrium price that buyers were paying before the tax and see how that increased. How much did that increase by when we implemented the tax? So we see that the price went up by $1.30. So we would say the buyer's incidence is $1.30. The seller's incidence, similarly, is going to be found by comparing what sellers get to keep now compared to what they got to keep before the tax. So they used to get to keep the entire equilibrium sales price. Now they keep $6.30. So the seller's incidence is 70 cents. They're 70 cents per unit worse off than they were before. So the bulk of the incidence falls on buyers in this case. And so one piece of information we could glean from this calculation is that the demand curve must be relatively inelastic compared to the supply curve, right? If they're bearing more of the tax burden. Right. So in addition to the incidence, there's a few other calculations we can do based on this problem. So we've already talked about the buyer's incidence and the seller's incidence. We can also calculate the tax revenue pretty easily. So the tax revenue is this area represented by this yellow rectangle here. We can calculate the area of this rectangle by noticing that one side of the rectangle is the amount of the tax, the other side of the rectangle is the after-tax quantity. So the total tax revenue is going to be the tax per unit multiplied by the after-tax quantity. 2 times 1166.7 will give us $333.30 worth of tax revenue. The deadweight loss is the reduction in total surplus that happens because we have distorted this market outcome. We have moved away from the efficient equilibrium quantity, right? And so what we need to do is find the area of the red triangle here. And so fundamentally we're using the area of a triangle here, 1/2 times the base times the height. So the height, if you want to call this dimension here, the height of the triangle, that's going to be the tax per unit. If you want to call this the base of the triangle, I think this is actually the height and this is the base, but whatever, it doesn't much matter. So the other dimension is the difference between the equilibrium quantity and the after-tax quantity. Okay, so the total deadweight loss then is going to be 1/2 times 2, which is the tax per unit, times this distance right here, which is the difference between the two quantities. We multiply all those things together, we get $133.30 worth of deadweight loss. And the interpretation here is this is the efficiency cost of introducing the tax.